everyone, I am here today to do our second part of laws of exponents. Today we're going to go over the last two things that I think are super important that are going to be helpful for you when we are doing our algebra work. So to get us started, let's first talk about the zero power. So when we talk about the zero power, what that means is anything to the zero power is 1. Yes. Seriously. It doesn't matter what the base is. Anything raised to the zero power is 1. So if I have 525 to the zero power, it's 1. X to the zero power equals 1. And this number, 125,443 raised to the zero power, is 1. Don't be trying to tell me that I did not tell you that anything raised to the zero power is 1, because I'm here to tell you anything raised to the zero power is always 1. So don't be this guy. Don't be like, why you no tell me. I did tell you, okay? So when we're working with expressions that have exponents of 0, we do need to be careful. Because just because you see a 0 exponent, the answer is not always going to be 1. And I know you're like, but that's what you literally just told me, Mrs. Lawrence, that if I see an exponent that is a 0, the answer is going to be 1. Kind of. What I mean is this. If I look at this 15x to the 0 power, I cannot say that that is 1. And here's why. 15x to the 0 power is really saying 15 times x to the 0 power. So if I break that apart, the x to the 0 power part is 1. So it's really saying 15 times 1. And 15 times 1 is 15. So that's what I mean when I say be careful, because that whole thing is not going to be 1. Just the x to the 0 power. Just whatever that 0 is attached to, that becomes 1. You still not getting it? Well, all right, let's look at another one. So if we have 6 times x to the 0 power times a to the second power. Again, that is saying 6 times x to the 0 power times a to the second power. All of that is not raised to the 0 power. Just the x's. So if I break that out, it's saying now 6 times 1, because x to the 0 power is 1. So 6 times 1 times a squared. And now I need to simplify. So 6 times 1 is 6, and then it's just a squared. Still not sure? Let's look at another one. Ooh, this is a little bit more complicated. 4x to the 0 power plus a squared b plus 10. There's a lot going on. It's a trinomial. I've got 3 terms there. Again, where I see 0 as an exponent, just whatever it's attached to is 1, not everything. So that means it's 4 times 1, because that x to the 0 power, that is 1, so it's 4 times 1 plus a squared b plus 10. So now I'm going to simplify that, and 4 times 1 is 4, so now I have 4 plus a squared b plus 10. But I can still simplify this trinomial, because if I look for like terms, I have 4 and I have 10. We can add 4 and 10 together, and so we can get a squared b plus 14. So just because we see that 0 exponent does not mean the entire answer is 1. Just the part that it's attached to can be rewritten as 1. So now let's talk a little bit about negative exponents. Negative exponents are a bad thing in math. You can't have negative exponents. It's like an improper fraction. It doesn't look right. It's not the proper way to write it. But we can get rid of negative exponents. But we can't just like erase the negative side. We got to do some math in order to like set it straight. So what we do is we shift the power from the numerator to the denominator, or vice versa. You're like, what does that mean? For example, if I have a raised to the negative n power, that just looks bad. So to fix it, I write it as 1 over a to the n power. So if you see what happened there was that a to the negative n power, it just got bumped to the denominator, and 1 stayed up in the top. Because remember, there's like a 1 that's in front of that a that's there. That 1 stayed up on top, but the part that had the negative exponent, it got bumped to the denominator. So let's look at one. So yeah, so Patrick's telling us that, right? So we just take the negative exponent and we put it down at the bottom. Thank you, Patrick. That is helpful. So let's look at an example. And And if we have 2 to the negative second power, so 2 to the negative second power, again, just like Patrick said, we're going to take that and we're going to put it at the bottom. So it becomes 1, and then 2 to the second power, it moves to the bottom. And 2 to the second power, I can simplify that because 2 to the second power is just 4. So it would be 1 over 4. We had 4 to the negative third power. I'm going to take that 4 to the negative third power, and I'm going to move it to the bottom. And when we move it to the bottom, it becomes positive. So now we have 1 over 4 to the third power. And I can simplify 4 to the third power. That is 64. So it's 1 over 64. And then if I have 1 over 7 to the negative third. Now, so this was where I'm talking about vice versa at the beginning. Because if it's in the bottom already and it's negative, denominator, I should use some proper math terms here. If it's in the denominator already and it's negative, to undo the negative part, we put it now into the numerator. We're going to put it on top in the numerator, and it's going to become positive. Watch, I promise. And you may be like, well, where'd the 1 go? The 1 is still there, but we don't write 1 as a denominator. That's just not the right way to write that. But it's really 7 to the third power over 1. But we don't write that. And that 1 kind of got closed up when we're going to multiply it with that 7 to the third power. And it becomes 343. So let's put this all together, shall we? So putting this all together, I mean a problem like this. I have a to the 6th power, b to the 0 power, and all that's going to be divided by 5 to the a to the 3rd power. So I'm going to break this apart, okay? Notice that 1 has replaced b to the 0 power, because remember, anything to the 0 power is 1. So we have a to the 6th power times 1, and on the bottom it's really saying 5 times a to the 3rd power. How did I get a to the 3rd power divided by 5? Well, if you remember, to divide exponents, this is like previous day, we talked about dividing exponents. So I subtract the exponents when I have to divide. So a to the 6th power divided by a to the 3rd power, I keep the a, and I take 6 minus 3, which is how I got the 3 on top. And then the 5 just stays on the bottom. The 1 times anything is just whatever it is. So 1 times a to the 3rd power is just a to the 3rd power. So let's look at this one. 8x to the negative 2nd power, b to the 0 power divided by 4x cubed. There's a lot going on, but I'm going to break it down. So it's really saying a times x to the negative 2nd power times 1. Again, anything to the 0 power. So b to the 0 power is the same thing as 1. So that's where that 1 is coming from. Divided by 4 times x cubed. So if I start to simplify this, I need to move that x to the negative 2nd power. I need to, like Patrick told us, it needs to go in the bottom. So I'm going to move it to the bottom. So now you can see it's down here. But 8 times 1 stayed on top. The only thing that got moved was x to the 2nd power. When I moved it to the bottom, the negative sign goes away. And this is all still on the bottom. So now I'm going to simplify. Can we take 8 times 1? Yes. Oh, I forgot about my little guy coming up. Yes, so saw the negative exponent. Remember, it goes on the bottom of the fraction. Yep, we did that. So 8 times 1 is 8. And then I have 4 times x cubed times x squared. Again, if we are multiplying in the variables and there's exponents, keep the base the same. So we keep the x and add the exponent. So 3 plus 2 is 5. So it's going to be 4 times x to the 5th power. But I think I can simplify that even more because 8 divided by 4, that is math that we can do. 8 divided by 4 is 2, so it becomes 2 over x to the 5th power. Okay? So, my work for right now is done with this video. It is not done in helping you if you still need help. But I would like you to first go and complete the practice in Schoology. There's the awesome exponent rules that we have talked about, okay? So go ahead and practice those. If you need help, please make sure you reach out, and I will see you all soon. Bye!